Okay, we are moving on to section 5.4, solving compound inequalities. So first, let's define a compound inequality. Compound inequality is an inequality, well actually, two inequalities separated by and or. Okay, so and or. Two inequalities that are separated by the words and or. And compound inequalities. Basically, it would be like saying, let's go greater than -2 equal to 3. Let's say we're working with this example. This is what your compound inequalities are going to look like when they are and, okay? You're going to read the variable first. So this is basically saying x is greater than -2 and x is less than or equal to 3. Remember how I said over and over and over again to make sure that you always read the variable first. Okay, x is greater than, because this side is opening towards the x, -2, and x is less than or equal to 3. So when we graph this on a number line, let's say -2 was here and 3 was here, we would have x is greater than -2. So if it's greater than, it's going to be an open circle. Since it's greater than, it's also going to be going to the right. And then it also says and. That means that it has to satisfy both inequalities. Anytime you see the word and, means it has to satisfy both inequalities. So x can be greater than -2 and less than or equal to 3. So this would be going this way. And they would kind of overlap here in the middle. Okay, it does not keep going, it stops. Because it has to be between -2 and then less than or equal to 3. Okay, so any number in between or equal to 3 works for this inequality here. Okay, so when you're solving a compound inequality, and it's an and, whatever you do to the middle, you have to do to everything. So you're pretty much solving for the middle is ultimately what you are doing here. So this problem says 10 is less than or equal to 3k minus 2 less than 19. So basically what you're going to be doing here is solving for the middle. So what's happening to k here? What's happening to k is it's being multiplied by 3 and then subtracted by 2. So we are going to do the reverse opposite. Instead of subtracting 2, we are going to add 2. Instead of multiplying by 3, we are going to divide by 3. But when we do these things, we need to make sure that we actually apply these to everything. So when I add 2, I'm not just adding 2 to one side or the other, I'm actually adding it to everything. It's going to cancel out in the middle. I'm left with 12 is less than or equal to 3k less than 21. Now from here, I need to divide by 3. I'm not just going to divide by 3 to the middle, I'm going to divide by 3 to everything. And hopefully you guessed it, if I was dividing by a negative number, I would still flip the sign. So I have 4 is less than or equal to k less than 7. So when I graph this, I'm going to graph this. Remember, you read the variable first. K is greater than or equal to 4, so we're going to start with that. So we're going to go to 4. We're going to do a solid dot because my K can equal 4. And we're going to start going to the right because it's greater than. Except it also says K is less than 7. And because this is an and, it has to satisfy both of the inequalities. So I'm going to have an open circle on 7, okay, because it's just less than. And my line's going to be going this way. That means that my answer has to be in between these 2 points or equal to 4. Moving on to OR inequalities, compound inequalities. Your solution can satisfy one inequality or the other. It does not have to satisfy both inequalities. It can satisfy one inequality or the other. In order to do that, solve each separately. Okay? So example 2 says x plus 3 is less than 2 or negative x is less than or equal to negative 4. So it has to satisfy one or the other. So first we want to solve. In order to solve the first one, pretty simple, we're just going to subtract 3. And we get x is less than negative 1. Then over here we have negative x is less than or equal to negative 4. In order to get rid of something that's being multiplied by negative 1, we are going to divide both sides by negative 1. Except, since I'm dividing both sides by a negative number, I need to flip my sign. So instead of less than or equal to, it becomes greater than or equal to. Negative 4 over negative 1 is 4. And then you are also going to graph each of these separately as well. X is less than negative 1 is going to look like an open circle on negative 1 going to the left. And x is greater than or equal to 4 will be a solid circle greater than going to the right. So this is saying that any number that is less than negative 1 or greater than or equal to 4 will satisfy this inequality. It does not need to satisfy both. It needs to satisfy one or the other.